friends, how are you? I hope you are doing well. I am Manas from ARYABHATTA Career Academy. Two things are infinite, the universe and the human stupidity. And I am not sure about universe, but I am sure about the human stupidity. The saddest aspect of life right now is that science gathers knowledge faster than society gathers wisdom. So children, there cannot be better choice than in current electricity to spark our life, to gather knowledge. So it is time to start this topic from current electricity. It is one of the important topic so far as 10th class is concerned. At the same time, it is also very important for plus 2 level. Today in this video, what I am going to discuss, since it is the introduction class of current electricity, definitely will discuss some of the concept of current electricity. You can say the electricity or you can say the electric current, no matter. So children, without delay, it is better to start the topic. So today I said now it is introduction class, few concept I shall discuss, but in the coming videos the entire topic, what are the contents are there, definitely I shall cover, no doubt at all, with numerical problems. So it is better to start now. One question comes to my mind: what is electricity? Electricity, it is a set of phenomena which is associated with the charges either at rest or in motion. Phenomena in the sense, the fact what we observe. I said that it is a phenomenon associated with the charges. The charges may be at rest or the charges may be in motion. So today in this class, in this video, I am going to explain the concept of charge. What is charge? In fact, it is one of the basic property of matter. You can say the fundamental property of matter. I can write it as the fundamental property of a subatomic particle that causes it to experience a force while it is placed in electromagnetic field. What I will tell? It is one of the fundamental property of matter or basic property of a subatomic particle. Subatomic particle in the sense the particles present inside the atom, what you have been learning from the earlier classes. So I said that it is a fundamental property of a subatomic particle that causes it to experience a force when it is placed in electromagnetic field, or you can say when it is placed in electric as well as magnetic field. You know that a charged particle creates a electric field surrounding it. At the same time, when a charged particle is in motion, it creates a magnetic field. That means in moving time it creates a magnetic field, otherwise it creates an electric field. That means the combination of electric field and magnetic field, I have mentioned here electromagnetic field. So charge is something which experiences a force when it is placed in electromagnetic field. So I can say that the charge is the basic property of all matter, no doubt at all. Earlier classes you might have studied about the static charge, means the charged particles when at rest. The thing is that when two non-conducting substances, for example, a glass rod and silk cloth, rubbed against each other, there is a transfer of electrons from one body to another body. Conventionally, we accept it there is a transfer of electron from a glass rod to the silk cloth. So glass rod losing the electrons becomes positive charge, conventionally we accept, whereas the silk cloth gaining the electron, it becomes negative charge. It is conventionally accepted glass rod is positive, whereas the silk cloth is negative. So it is clear that there are two types of charges are there. One is positive charge, whereas the other is negative charge. Generally, positive charge we mention as plus Q, negative charge we mention as minus Q. We use Q for the charge purposes. Some places we can use also capital Q. It is not a matter. So let us discuss more about the nature of the charge. So before that, I would like to say that mathematically I can write charge is the product of current and time. What is the unit of charge? Its SI unit is coulomb. Shortly we write C. It has also some other units, very smaller units are there, like microcoulomb, millicoulomb. 1 millicoulomb is equal to 10 to the power minus 3 coulomb. 1 microcoulomb is equal to 10 to the power minus 6 coulomb. 1 nanocoulomb is equal to 10 to the power minus 9 coulomb. So the SI unit of charge is coulomb. The thing is that the quantity of its charge on a body is measured by seeing its deficit or excess of electrons. The charge is measured from its deficit or excess of electrons. If there is deficit of electrons, the charge is positive. If there is excess of electrons, then we can say that charge is negative. So I can say that the quantity of a charge on a body is determined by the quantity of charge on a body is determined by the deficit of electrons, means positive, or excess of electrons, means negative. If it is a insulating substance, or you can say non-conducting substance, the charge particles resides at a point. It depends upon the either excess of electrons or deficit of electrons at that point. If there is deficit of electrons, we say it is positive charge. If there is excess of electrons, we say it is negative charge. So I can say that the charge of a body completely depends upon the electrons. If there is excess of electrons, negative. If there is deficit of electrons, it is positive. So it can be measured by like this way. It may be positive or it may be negative. That's why we written plus minus Ne. What N stands for? N stands for number of charge particles, where E stands for charge of electron. So charge can be calculated as the product of number of charge particles and charge of each particle. So mathematically I can say that Q is equal to N into E. So I said that the SI unit of a charge is coulomb. So the charge of an electron is charge of an electron equal to 1.6 into 10 to the power minus 19 coulomb. That means, see, 1 coulomb charge contains 1 by 1.6 into 10 to the power minus 19 electrons, or you can say that 6.25 into 10 to the power 18 number of electrons are present in 1 coulomb of charge. So let us discuss about the characteristic properties of the charge particle. Already I have mentioned there are two types of charges are there. One is positive charge, whereas another is negative charge. But positive negative depends upon either deficit or excess of electrons. If there is deficit, it is positive. If there is excess, it is negative. Okay. So one is, we can say that attraction and repulsion. Already you have been studying from lower class that like charges repel each other, whereas unlike charges attract each other. This is the attraction and repulsion property. Second property is the induction. What is induction? Suppose a charged body comes near another body which is already uncharged. You think that A is a charged body. You think this is positive charge. B is a neutral body, means neither positive nor negative. What happens? An opposite charge develop here. Since it is positive charge, here will be the negative charge. That means the body B gets charged by induction without making it contact. It became possible. This is called the electric induction, or you can say induction of charge. Third property is that charge is quantized. Very important point. Charge is quantized. What is charge quantized? An object is electrically charged means we understood either it is an excess of electrons or deficit of electrons. But the excess or deficit definitely some whole numbers. You can say that there is a deficit of 1.5 electrons, there is deficit of 2.001 electrons. We can say like that. We can say there is a deficit of 5 electrons, maybe 10 electrons, maybe 20 electrons. Definitely that number is a whole number. So excess or deficit of electrons must be a whole number multiplication of a charge of an electron, no doubt at all. So I said that charge can be quantized. So next property is that charge is conserved. Electric charge is conserved. That means charge can neither be created nor can be destroyed. That means the net charge in an isolated system is constant. Earlier I said that suppose you are rubbing a glass rod with a silk cloth, there is a transfer of electrons. How many electrons glass rod is losing? Same amount of electrons gained by silk cloth. As a result, total number of charge before rubbing and after rubbing, it is constant. So I said that the electric charge is conserved. So can you say me, can a charged body attract an uncharged body? Is it possible by a charged body to attract an uncharged body? Definite. It is possible. How? Suppose This is a charged body, positive charged body. It brought near an uncharged body, means neutral body. If positive charged body comes here, definitely the negative charged particles, those are here, they will be attracted. Why? Because the charged body produces something. What is that something? That is nothing but the electric field. As a result, the charged body exerts some force, applies some force. Due to that, negative charged particles are attracted towards the positive body. So you can say that this side becomes positive, this side becomes negative. So definitely there will be attraction between positive and negative. So I can say that a charged body can attract an uncharged body. So I can say that there are two types of charges are there. One is positive charge, one is negative charge. And it is the fundamental property of every object or every body. So, charge has its own identity. The charge has its own electric field. The electric field has its own existence. If there is no other charge particle in its vicinity, no problem. Still the charge particle has an electric field. So children, today's class just I explained about the charge. So in the next video, definitely we'll discuss more about the current electricity, which is related with the charge. One more thing I would like to say. Are you thinking charge is a scalar or vector? If you are thinking that charge is a vector quantity because it flows from one body to another body, definitely you are wrong, because charge is a scalar quantity. Why it is scalar quantity? Definitely I shall expose in the next class. Thank you. Jai Hind.